and we'll take a look at the next side. I hope the front side went well. We're going to move to the back side of that worksheet now, and we're going to be working a little bit backwards to be filling in the table below with the formulas now for each compound. We're going to use our table listing the oxidation numbers. This is going to be a combination of the periodic table, and it's also going to be our polyatomic ion table. Here's our polyatomic ion table over to the right side here. So let's go through. We're going to work kind of across and down this table at the same time. We're going to start with sodium. Let's go figure out what the ion that sodium turns into when it makes its valence shell full. If I look to the periodic table, I see that sodium will give up one electron, which is going to turn it into a positive 1 ion. And chloride. Chloride here is actually just regular chlorine that has gained the electron it wants to gain to become the ion. Cl minus 1 is how much the ion is for chlorine. That's a little minus 1 there. So we're going to call it chloride to indicate that it's chlorine that has gained the extra electron and become a little bit more negative. Now what we're going to do is fill in with our chemical formula. We're always going to write the positive, we call it the cation, but you can just remember that it's the positive element first. So sodium is our positive 1, and that's going to match up perfectly with the chloride, which is just a negatively charged chlorine atom. They're going to cancel each other out to make a neutral compound, or neutral molecule, because you got plus 1 sodium matches up with minus 1 chloride. Now let's move across the row. We've got sodium, and it's going to match up with chlorate. Now chlorate is a little bit different. That's going to be from our polyatomic ions table. I see chlorate is right here, and it's actually a combination of chlorine linked up with 3 oxygen atoms. And overall they kind of behave as one big group moving around together with a negative 1 charge. You can see I've written it here, and it's also over here on your oxidation number. That's nice that the chlorate has a negative 1 charge because it matches up easily with sodium to be the molecule Na, and then your chlorate, which is ClO3. That's my little 3 there. Let's move to the next one. We've got sodium again matching up with hydroxide. I check out my polyatomic ions table and I see hydroxide located right here, and it is the polyatomic ion, an oxygen bound up with a hydrogen to be OH, and it also carries a minus 1 charge, which again is nice because sodium links up with one group of hydroxide to be NaOH, or sodium hydroxide. We've actually used this chemical in lab. The next one along the row here, sodium is going to link up with carbonate. Carbonate is down here on the table of polyatomic ions, and things are going to get a little more interesting. You'll notice that carbonate has a minus 2 charge. Sodium only has a plus 1 charge. So how are we going to cancel those out? Well, we're going to have to use 2 sodiums linked up with 1 carbonate polyatomic ion to make that neutral molecule. We had to take 2 of these plus 1s, 2 of the 2 electrons getting kicked off of sodium, and 1 carbonate can accept 2 electrons. Now we move down to phosphate on the polyatomic ion chart, and we see that phosphate carries a minus 3 charge. It can hold on to 3 extra electrons, making it 3 extra negative charges. So how many sodiums do we need to make that work? Well, each sodium gives 1, so we're going to need 3 of them linked up with a group of PO4. Let's skip down one just to take a look at ammonium, which is over here on our polyatomic ions. Ammonium is NH4, and it carries a plus 1 charge, so I can indicate that that's going to always be plus 1. Now I'm going to have to match it up. It's going to be pretty simple to match up with these first 3. I think you can do those on your own. To match up with carbonate, though, Our carbonate down here on our polyatomic ion chart is -2. Ammonium is only +1. So we're going to have to do a little bit of trickery here. We're going to put our ammonium in parentheses, our NH4 ammonium, and we're going to indicate that we actually need 2 of them to match up with this -2 charge on the carbonate. So we've got 2 of these NH4 groups, and they're going to then match up with the CO3. Now the reason I did that, instead of writing NH2N8 CO3, this tells you it has the same number of each atom as what we wrote, but the information here is just not right. Really, we want to treat those NH4s as a group, because the N is really bound up tightly with those 4 H's. The N's aren't bound to each other at all, which is sort of implied by saying N2. And we just keep those as separate groups that move around as a unit. Okay, try to fill out the rest of this table, and then pause the video before moving on to naming these compounds. Okay, welcome back. Hope the table went well. We're going to be naming some compounds now, which is actually not as difficult as it seems once you get the tricks down. Let's do a couple together. We're going to start off here with Fe, which we remember is iron, and OH, which is an oxygen and a hydrogen, but really, because it's a polyatomic ion, we're going to refer to it by its polyatomic ion name, which is hydroxide. Remember, it's really moving around as a group. To name it, we just say the positive ion first, or we write it down, I guess, iron, and then we write down the second ion's name, in this case, hydroxide. When we use a polyatomic ion, we don't change its name at all, we just keep the exact same name. Let's go take a look at this one over here, though, for a different example. We're going to say the positive atom first, so it's going to be calcium. But then our second atom, our second element here, bromine, is now in its ionic form because it's in an ionic bond, and so we're going to call it bromide instead of bromine to indicate that it's in this negative side of an ionic compound. See if you can follow the rules through. Remember, polyatomic ions keep their name. Single elements, like bromine here, even though there's 2 of the bromines, it's just bromine, is going to change into bromide because it's the negative side. Let's take a look down here, though, for a little tricky one. We got to notice that this is NH4, which operates as like one unit again. It's that polyatomic ion, ammonium. And so instead of writing nitrogen, hydrogen, we're going to write ammonium to let folks know that we're talking about a nitrogen bound up with 4 hydrogens. And then the second side there is, again, hydroxide, and because it's a polyatomic ion, we don't change the name at all. Hydroxide. Okay, go ahead, practice through. Once you're finished, take a look at the answer key, which is up on the back bulletin board between the flag and Chief Joseph. If you get anything wrong, really figure out what you did wrong. Don't just copy the right answer down. Go learn how to do it. All right, good luck.